Hi there, today I'm going to talk to you about a parent graph. This parent graph is going to be of a line. The general form of this equation is y equals mx plus b. In this equation we have an x and a y value. Those represent points. When we've got our slope and our y-intercept filled in, x and y are points, and we could end up with an infinite amount of points from our line. M is slope, and if you're not quite sure about slope or you'd like some more information on that, please check out my slope video. We also have B, which is our y-intercept. So this is my slope, and that would be my y-intercept. Your y-intercept I like to think of as the starting point. And then you apply the slope from the starting point. So let's take a look at a few examples of this, and we'll just put it into action here. Actually, first, before I do that, I should talk to you about some slopes really quickly, just slightly. So we have slope. If m is positive, your line will be moving in that general direction. If m is negative, your line will be moving in that general direction. You can have a zero slope, which would be a totally flat line like that. Or you could also have a line, a vertical line like that, and that slope is undefined. I will talk to you about that more in my slope video, so if you'd like more information there, please check that out. But that's the general direction. That's how I think about slope. So now we're going to put it into play, please. Y equals 2x plus 3. So from this, I have a b value on the back end right there. That is my y-intercept. So b equals 3. But it is a y-intercept, so it is actually a point. And since it's a y-intercept, it has an x value of 0. So that is actually your starting point on the graph, and that is a very, very, very important thing to understand. It's not 3. It is actually a point 0, 3, or 0, your b value, and pay attention to that sign. You have a slope, and your slope is 2. And I like to think of slope as a rise over a run, so we will be going up 2 and over 1, up 2 over 1, up 2 over 1, and you will repeat that. Now this is a positive number, so my line must be moving in this general direction. So I'm going to slide this up, make a little room, and create some axes here. There we go. Now I'll grab a different colored pen super quickly, just so we can see the different graphing here. Okay, I'm going to start at 0, 3. So 0, 1, 2, 3. That is my starting point, my y-intercept, and then I apply my slope of 2 over 1. So up 2 over 1. Well, if I go up 2, I need to make sure that my line looks like this and moves in that direction. So if I jump up 2, you can say, well, do I move right or do I move left? If I were to move left and connect those two, my line would be going in that direction and it would be a negative slope. So that's not going to work. So if I jump up 2, I'm going to need to move over to the right. And if I were to connect those two, you can see that is the direction of my line. Now it matches up with that positive slope. And you can repeat that process an infinite number of times, up 2 over 1. Well, now if you wanted more points, you could drop 2. And then you're kind of asking yourself the same question, well, left or right? Well, if you want them to line up with these, let's move here to the left, down 2 over 1, down 2 over 1, down 2 over 1, all the way to infinity if you would like. Then we come through, and you really should be using a straight edge, but for the purposes of illustration, I am just going to make it a squiggly, horrible looking line. But when you do this, please use a ruler. I would appreciate that, and everybody else would probably appreciate that also. So there you go, there's your line. A line is made up of an infinite number of points. There's a point there, but I could also say that there's a point there, 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 and I could keep going on and on and on, but I won't do that because it'll probably get annoying. Now you can ask yourself, domain and range. Domain, all real numbers. Negative to positive. As it goes down and as it moves up, it will continue to get wider. Range, same concept, all real numbers, but this time moving from the bottom to the top, all y values will be represented. Is it a function? Yes. Asymptotes? No. So there's an example. We'll look at a couple more right here. Let's look at y equals negative 2/3 x minus 1. Okay, so coming in here, let's create some axes. X and y axis. Well, I have a starting point. That would be 0, 1. So my b value equals negative 1, but it's actually a point, 0, negative 1. Great. I have a slope, negative 2/3. So I'm going to be starting at 0, negative 1. That's where I begin, the y-intercept. And then I apply my slope up 2 over 3. Up 2 over 3, but it's negative. So negative line will be moving in that general direction. So if I go up 2, I better make sure I move over to the left this time to get my line going in that direction. Whoa, excuse me. I should have been over 3. Up 2 over 1, 2, 3. My apologies. Let us ignore that point right there. That doesn't count. And then from this, up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Then we could do the same thing moving in the other direction. If I drop down 2, well, hopefully you can see to make this line up, I would need to move to the right. Down 2 over 3, down 2 over 3. And there you go. That would line you up. Use a straight edge if you have one, please. There's a nice representation of my line. Domain, all real numbers. Range, all real numbers. Function, yes. Asymptotes, no. Okay, we will take a look at 2 more of these. Then you can be finished for the day. And say, look, I've done some great parent graphs with lines. Now I know all there is to know. Let's look at y equals 2. This is a really interesting one. A lot of people have some problems dealing with this here. And it's really going to be one of 2 options. It will be a vertical line or a horizontal line. If you can't remember which is which, a very, very, very easy way of figuring it out would be to create a very quick XY table. This tells us what y is. It says y is 2. Y is 2. So you can make y 2, and then you can make x whatever you'd like. Let's say 1. Well, what does y need to be? It needs to be 2. You can make x whatever you'd like. What does y need to be? 2. You can make x anything you'd like, and you can plot those points. 1, 2, 0, 2, 2, 2. You can see those values there. That would give us our line. Should have been straighter and should have been through those points. My apologies. Domain. Ooh, all real numbers. Range. What is my range? Well, what are the y values that are represented? Nothing here, nothing here, nothing here. You have a single y value at 3. And then as you keep going up, nothing is represented there. Is it a function? Well, yes, it passes the vertical line test. Asymptotes? No. Do one more. Now let's look at, let's say, x equals 2. Probably going to be a very, very, very similar concept and similar idea, except for the fact that if you don't know what this thing looks like and you're not sure, well, let's do the same thing and you're going to see the differences. Well, here, x is 2. So y can be whatever you'd like. X is 2, y can be anything. X is 2, y can be anything. 2, 0, 2, 1, 2, 2. You can see those points lining up. Here is a vertical line. This slope is undefined. Let me slide up. This slope right here is a zero slope. That's the difference between those two. Okay, domain, same concept, same idea. Well, as you slide across, we don't have any x values represented here. We encounter an x value there at 2. And then you go on and there's nothing represented, so x equals 2. Range, coming from the bottom up, all real numbers. Function, well, does it pass the vertical line test? No, our single input of 2 has multiple outputs. It is not one-to-one, not a function, asymptotes. No. Thank you much.